think about the computer you're using right now, or, maybe the smartphone sitting in your pocket. I want you to ask yourself a very simple question. How much memory does it actually have?
Right. I mean, if you're on a standard laptop, maybe you're working with, what, 8 gigabytes?
Yeah, exactly. Or if you're a power user, maybe you sprung for 16 or even 32 gigabytes.
And for most of us, that feels like plenty. You have dozens of browser tabs open, you're streaming audio, you're running complex spreadsheets, and the machine handles it all without breaking a sweat.
It feels infinite.
It really does. It feels like you could throw anything at it.
But today, we're going to completely shatter that scale because Apple is reportedly planning to release a new Mac Studio, and, well, the rumors are pointing to a machine with 1.5 terabytes of memory.
Which is just, I mean, it's absurd.
It is. And just to be absolutely clear here, we are not talking about storage for your photos and videos. We're talking about working active memory.
Right, RAM, which is a frankly staggering number for a single piece of desktop hardware. A number that large, it completely redefines the boundaries of what a local on-premises machine can actually do.
Okay, let's unpack this because this isn't just some hardware flex from Apple. Today, we're doing a deep dive into the future of enterprise AI. And we're pulling from a really fascinating breakdown by Dr. Errol Brandt on the YouTube channel Kira.
It's a great source, really detailed.
It is. And our mission for this deep dive is to explore how the seemingly niche, ridiculously oversized hardware update could completely upend the economics of artificial intelligence.
Oh, absolutely.
We are talking about potentially killing the business case for those massive multi-billion-dollar cloud data centers.
Right, bringing highly advanced AI right back into the everyday office.
Exactly. But, to understand why a 1.5 terabyte machine is such a massive threat to the cloud, we have to look backward first to a very expensive lesson Dr. Brandt learned about how Apple builds its chips.
Yeah, the hardware architecture is really the foundation of this entire shift. And Dr. Brandt tells this fantastic story about his own development journey to illustrate it.
I loved this part.
Right. So about 7 years ago, he was building out his idea for an analytical data frame, which was the core of what would eventually become his business intelligence engine.
Okay.
And to do this, he needed serious computing power. So he went out and bought a top-of-the-line Mac Pro.
Oh, I remember those. The ones that famously looked exactly like a giant metal cheese grater.
That's the one, a $12,000 cheese grater.
Good Lord. 12 grand.
Yeah, it was an absolute beast of a machine at the time. But then, a little while later, Apple released the M1 MacBook Air.
Which is just an entry-level fanless laptop, right?
Exactly. It cost about $1,500.
And here is the kicker in his story. He starts playing with this thin little laptop, and he realizes it is actually outperforming his $12,000 behemoth.
Yes. The performance gap was so shocking to him that he actually sold the expensive cheese grater, bought the M1, and even wrote an email to Apple CEO Tim Cook just to thank him for the M-series chips.
Did he hear back?
He didn't get a reply, unfortunately.
Oh,
It probably got lost in a sea of fan mail. But, the reason that $1,500 laptop could completely destroy a $12,000 workstation comes down to a very specific engineering choice Apple made.
right.
It's called unified memory.
So I am trying to wrap my head around this unified memory thing because it seems to be completely different from how traditional computers are built.
It's a radical departure.
Yeah.
So in a traditional setup, your computer has a central processing unit, the CPU, and a graphics processing unit, the GPU.
Like a graphics card.
Exactly. And historically, they each had their own separate pools of memory. If the CPU was working on a complex math problem and needed the GPU to render it visually, the data literally had to be copied and sent across the motherboard from one memory pool to the other.
Like physically traveling across a bridge.
Exactly that.
Yeah.
And no matter how fast that bridge is, copying data takes time. It creates a massive bottleneck.
Right, I see.
So what Apple did with their M-series chips is they put the CPU, the GPU, and the neural engine all under the exact same silicon chip. And they all look at the exact same single pool of memory.
So there's no copying.
None. There's no traveling across a bridge. If the CPU has the data, the GPU instantly has access to it too. What's fascinating here is how this directly contrasts with the architecture that companies like NVIDIA use to build their massive data centers.
Oh, interesting. How so?
Well, NVIDIA's approach is highly specialized. Their hardware is absolutely incredible for one specific task, which is training massive foundation models.
Like OpenAI training ChatGPT.
Exactly. When you need to ingest the entire internet to teach an AI how to speak, NVIDIA's architecture is king. but it is surprisingly inefficient for what we call inference.
Inference being when you are actually using the AI, right? Like when a business asks its internal AI a question and the AI has to infer the answer from the company's data.
Spot on. Training is learning the language, inference is having the conversation.
Ah,
And NVIDIA's data centers are built to learn the language. Unified memory, however, absolutely excels at inference. It is perfectly designed for running complex, everyday organizational tasks really quickly.
wait, let me see if I can visualize this. If NVIDIA is like a massive factory
Right.
custom built to manufacture massive quantities of a single product, is Apple more like a high-end commercial kitchen?
Well, like that.
Like instead of having a separate building for the vegetables and a separate building for the meat, all the chefs, so the CPU, the GPU, the neural engine, they're all standing around the exact same prep station.
Yes, they're sharing the exact same ingredients instantly.
Right. It makes it way faster to actually serve the meals.
That is a brilliant way to frame it. The commercial kitchen is built for serving the customer right now, handling diverse orders on the fly, which is exactly what inference is. The factory is built for creating the raw materials, which is training.
But hold on, if we're packing all these powerful chefs around one single prep station, how does the machine not just, melt?
Well-
Yeah, I mean, my standard laptop sounds like a jet engine taking off if I open too many browser tabs. If a business runs an enterprise-grade AI locally, wouldn't the heat and power consumption just fry a desktop machine?
Well, that would absolutely happen with older architectures. And it's a huge reason data centers exist. They have massive industrial cooling systems.
Right, all those server fans.
Exactly. But Apple's M-series chips use ARM architecture. They were originally designed for smartphones, where obviously you can't have a cooling fan.
Oh, right.
So they're designed to sip power rather than gulp it. You get this massive commercial kitchen output without generating the heat of an industrial factory.
Okay, that makes total sense. But it brings up an even bigger question.
What's that?
So Apple creates this perfect, highly efficient commercial kitchen. Why are developers still ordering takeout from the cloud?
That's a great way to put it.
I mean, if they have this hardware and they've been using unified memory since the M1, why isn't every business running their AI locally right now?
That is the multi-billion-dollar question.
Hmm.
Because having the ultimate commercial kitchen doesn't matter if the chefs are refusing to use the appliances.
Right.
There is a glaring software gap holding this hardware back.
It's definitely not a lack of tools, though, because the source points out that Apple has released frameworks like MLX, Core ML, and Core AI.
Yes, they have.
And these tools allow developers to run open-weight models locally, and they let you quantize them.
Right.
Actually, let's pause there for a second, because quantization is a word getting thrown around a lot. What does that actually mean in plain English?
So think of it like taking a massive, dense textbook and summarizing it into a pocket guide.
Okay.
AI models are essentially giant webs of mathematical weights, usually stored as highly precise decimal numbers. Quantization chops off the long tail of those decimals. You just round the numbers down.
Oh, wow. Does that ruin the AI?
Surprisingly, no. It takes up a fraction of the storage space and requires way less memory to run. But shockingly, the AI stays almost as smart. It allows massive models to run beautifully on local hardware.
Okay, so the tools exist to shrink the models, and the hardware exists to run them. Why aren't developers taking advantage of this?
Because, developers are human beings under immense pressure.
Fair enough.
When they are building applications in the real world, they have tight deadlines, demanding clients, and their primary goal is just to get a minimum viable product, an MVP, out the door as fast as possible.
So they take the path of least resistance.
Exactly.
Which in the AI world usually means programming in Python and just calling an API in the cloud.
Yeah, it's fast, it's easy, and it works. But Python essentially abstracts away the hardware.
Meaning it doesn't talk directly to the Apple chip.
Right. Because developers aren't taking the time to write highly optimized code specifically for Apple's architecture. The incredible power of that unified memory is completely wasted. The CPU does a little bit of work, and that incredibly powerful GPU mostly just sits there, completely idle.
Oh, man. Dr. Brandt has this brilliant analogy in the source material for this exact situation.
Oh, the car one.
Yeah. He says that building AI apps on Apple right now is like buying a Formula One car and driving it to the shops in first gear.
It perfectly captures the frustration. You have an engineering marvel sitting on your desk, but because you're just popping down to the grocery store of simple software development, you never even let the engine roar.
Here's where it gets really interesting, though, because the solution isn't just, telling developers to try harder or learn better coding languages.
No, not at all.
Dr. Brandt actually argues that developers are acting rationally. It's not their fault they are stuck in first gear. It's because there is a massive fundamental layer of software completely missing from the Apple ecosystem.
Yeah.
What exactly is this missing layer?
He calls it the enterprise engine or the orchestration layer. Think about it from the developer's perspective. Your job is to build a user interface that helps a company analyze its daily sales. You are not going to stop your work to hand-tune a metal shader.
Wait, what even is a metal shader?
It is highly specific code that talks directly to the microscopic cores on the graphics card. It is manually assigning tasks, telling, like core number 42, to multiply this specific matrix, while core 43 does something else.
That sounds miserable.
It is incredibly tedious, low-level programming. You also aren't going to spend 3 months building a complex telemetry stack.
And telemetry is what exactly?
Telemetry is essentially the nervous system of an application. It's automated, constant data collection, checking the health of the system.
Like, is it crashing?
Right. Is the memory overloading?
Okay.
Are we taking too long to answer a query? Did the database connection drop? Developers don't want to build that from scratch for every new app.
Because why would you add months of brutal complexity to your project to solve a problem that you don't even have yet?
Exactly.
Your simple MVP works fine in first gear.
The developer's job is the application. But for that application to run efficiently at an enterprise scale, meaning for a whole company to rely on it daily without it crashing, it needs an underlying engine that manages all the hardware resources perfectly.
And right now, very few people are building that engine for local Apple hardware.
Right, because it is deeply unglamorous work.
Unglamorous is putting it mildly. Dr. Brandt lists out what this missing orchestration layer actually consists of, and it sounds like an absolute nightmare.
It really does.
We are talking about managing job queues, batching requests so the system doesn't get overwhelmed, constant security auditing, and failover systems so things don't crash. He literally says that doing this kind of underlying architectural work makes a neurotypical person want to eat crushed glass.
That visceral reaction is exactly why it's missing. It's tedious, frustrating, invisible plumbing.
Right.
But without that plumbing, you don't get running water.
This totally shatters the marketing myth that big tech tries to sell us. You know, we've all seen the commercials. The promise that you can just take a messy corporate spreadsheet, upload it to a magical cloud AI, and instantly get a perfectly formatted, boardroom-ready analysis.
But Dr. Brandt has a very colorful term for that marketing promise.
He calls it frog shit.
He does not hold back.
No, he doesn't. But think about your own company's shared drive right now, or your internal databases. They are a mess, right? Decades of legacy data, weird formatting, missing fields.
Exactly. If you feed messy, real-world data directly into an AI model without an orchestration layer to clean, validate, and manage it first, you are going to get garbage out.
Right.
AI is not magic. It's a statistical engine. It needs pristine conditions to give you accurate business insights.
This leads us to what he calls the 60-30-10 rule, which completely blew my mind and really reframes how we should look at this entire industry.
That's a great breakdown.
We keep talking about AI, but the actual intelligence part is tiny, right?
It really is. The 60-30-10 rule states that when you look at a fully functional enterprise-grade AI system, the actual artificial intelligence, the neural network, analyzing the prompt and generating the text is only 10% of the entire solution.
Just 10%? That's crazy.
Just 10%.
So what are the 60 and the 30?
The 60% is all the heavy data plumbing. It's the pipelines that ingest the company's files, clean out the formatting errors, update the vector databases, and manage security permissions.
Making sure Bob in accounting can't accidentally ask the AI to summarize the HR department's salary spreadsheet?
Exactly. You need massive systems just for that.
Okay, so that's the massive underwater portion of the iceberg, the 60%. What's the 30%?
The 30% is the user experience wrapper. It's the interface the employees actually click on. It's the routing systems that take a user's question, figure out which database to check, and handle the API calls.
So combined, that 90% is entirely comprised of boring governance and process control.
Yes. And Dr. Brandt actually spent the last 3 years building his Kier engine to be exactly that 90% orchestration layer.
Oh, I see.
It's the system that takes the crushed glass out of the equation for developers building on local hardware. If we connect this to the bigger picture, this fundamentally alters how businesses should value AI. Everyone is currently obsessed with the models themselves. Which company has the smartest AI? Which one scores highest on benchmark tests?
Right. He even calls building new models a pissing contest, noting that there is a better model released every single month. They've become mere commodities.
The magic isn't the model anymore. The model is cheap and easily replaceable. The real competitive advantage for a business is the orchestration system that wraps around the model.
Because if you don't have the plumbing, the smartest AI in the world is completely useless to a company.
Exactly.
But I'm looking at the sheer scale of what you were describing, and I just can't wrap my head around a local machine doing all of this.
Really?
Yeah, I mean, I understand the 60-30-10 rule, but if 90% of this is massive, heavy data pipelines, security routing, and indexing an entire corporation's knowledge, there's no way a desktop machine handles that.
You'd think so.
Even a 1.5 terabyte Mac Studio. Doesn't an enterprise-level company generate so much data that it instantly bottlenecks anything outside of a massive cloud server farm?
This raises an important question, and it is the exact assumption that keeps companies paying massive recurring bills for the cloud.
Because we think we need it.
Right. We have been conditioned to believe that corporate data is inherently massive. But Dr. Brandt provides a real-world example that completely shatters that assumption.
Okay, what kind of scale are we talking about here?
In his previous role, he worked for one of the largest manufacturing companies in Australia, a major enterprise doing $1 billion in annual sales,
Okay.
and managing a massive, complex inventory of 80,000 different products.
So serious, heavy enterprise data, not a small operation at all.
Now, how much memory do you think it took to hold that company's entire business planning model? All the data required to run the analytics for a $1 billion, 80,000 product operation.
Man, if we are talking about moving off the cloud, I'd assume thousands of gigabytes, multiple terabytes just to hold the active database.
It fit into roughly 400 gigabytes of memory.
400 gigabytes for an entire billion-dollar company.
Yes.
Just 400.
Why is it so small? That doesn't even seem possible.
Because we confuse consumer data with enterprise data. As consumers, our phones are full of terabytes of 4K video, high-resolution photos, and massive video games.
Right?
Those take up immense amounts of storage. But corporate business intelligence, it is mostly just text and numbers sitting in database columns.
Oh, wow.
A spreadsheet with 1,000,000 rows of sales data feels massive to a human, but to a computer, it is microscopically small. $1 billion in sales is ultimately just a few megabytes of text.
Oh, wow. I never thought about it like that. So when we circle back to the rumor that Apple is releasing a Mac Studio with 1.5 terabytes of unified memory.
It is vastly, absurdly more than enough.
So if a billion-dollar company only needs 400 gigabytes of active memory to hold all its text and numbers,
Yeah.
a 1.5 terabyte machine is basically asleep at the wheel.
It has so much overhead capacity that a medium-sized enterprise could run a top-tier AI model internally, manage all that messy 90% plumbing we talked about, and the machine wouldn't even break a sweat.
And this is the paradigm shift that people are missing. Over the next 3 years, companies generating tens or hundreds of millions in revenue are going to wake up to this reality.
Yeah.
They will suddenly realize they have access to top-tier enterprise technology that was previously only available to Fortune 500 companies renting out server farms.
So what does this all mean?
It means they can fundamentally shift their unit economics.
Right.
Instead of paying exorbitant recurring subscription fees to cloud providers for compute power, they can buy a single piece of hardware, put it in their office, and run highly advanced analytical workloads completely on premises.
The data never leaves the building.
Exactly. The
Right.
security risks drop, the latency drops, and the cost plummets.
But, and I guess this is the crucial caveat, they can only do this if they have that missing orchestration engine. Because the hardware is there, but without an engine like the one Dr. Brandt built to handle the 90%, developers will still be driving that Formula One car to the shops in first gear.
Exactly. But Apple has quietly positioned itself to dominate enterprise analytics. They have the hardware, the fuel, and the chassis.
They are empowering small and medium-sized businesses to own their AI locally.
By bypassing those big data centers entirely, they are rewriting the rules of the enterprise market.
That is an incredible journey we've just been on. I mean, we started with a $12,000 cheese grater getting destroyed by a cheap laptop.
All thanks to the magic of unified memory.
Right, the ultimate commercial kitchen for computing. We uncovered the software gap, realizing why developers are stuck driving Formula One cars in first gear, desperately avoiding the crushed glass of actual enterprise plumbing.
We learned that 90% of AI isn't the flashy intelligence at all. It's the unglamorous data pipelines and routing that makes messy, real-world information actually usable.
And finally, we brought the cloud crashing back down to Earth, proving that because corporate text data is surprisingly small, a 1.5 terabyte Mac has more than enough power to run a billion-dollar company's analytics right from a desk in the office.
It really is a black swan event for the tech industry. It's a shift in capabilities that few people are seeing clearly yet, simply because they are blinded by the hype of massive cloud models.
And that brings us to a final thought for you, the listener, to mull over long after you finish this deep dive. Throughout this discussion, we highlighted Dr. Brandt's view that AI models themselves are rapidly becoming mere commodities, easily replaceable algorithms in a never-ending, highly publicized contest.
Right.
He insists the true lasting value lies entirely in that unglamorous 90% orchestration layer. So if the actual intelligence of AI is becoming the cheapest, least important part of a business solution, what does that mean for the tech giants right now?
It's a great question.
They're currently spending hundreds of billions of dollars constructing massive new data centers, all desperately trying to build the next frontier model. But are they fighting a war for dominance over a 10% commodity that businesses armed with a powerful desktop Mac won't even need the cloud to use?